Okay, just a quick run through on some of the worked questions. There's some common mistakes coming up that a few people made on these. So question number one, the big mistake is people's resolution of the forces. What it says is a particle P of mass 0.5 is moving along the positive x-axis under the action of a single force. So we've got our origin and the particle P. P is moving positive x direction under a single force directed towards O. So the force is acting in the opposite direction. They tell us magnitude of the force is k over x squared. That's the magnitude. It doesn't include the direction. So the F here is equal to negative k x squared. Now, what happens in this is, if I want to turn this into a vector, the vector part of this doesn't come from that x squared, it comes from what you define as being your positive direction. So this is the bit that's missing, is this minus, because it's in the opposite direction to what x is displacing. Where k is a constant and the speed of p is v meters per second, and then we're given two situations to solve for. So what we need to actually do is now resolve all of this into terms of x. So turn this first of all into a is now minus k over x squared m. And then we need to remember that a has a differential form of v dv dx. So v dv dx, let's just scroll this down a bit. So v dv dx is equal to minus k over x squared m. Okay. What's that now? What's the force? Oh, the mass is half. Sorry, the mass is half. That's why it's messing around. So 0.5, so that gives us 2k x squared. Rearrange our components. So we've now got the integral of v dv v with respect to v is equal to the minus 2k, the integral of 1 over x squared with respect to x. I know some people just transfer the v and x. Personally, I think that's bad practice because the dv dx are infinitesimally small, so they only have meaning when they're either being divided or they're being summed. So now we need to do the integral of this piece. So integrating v is going to be v squared. The constant comes to the other side, and we get minus 2k divided by minus 1 from the result of integrating minus 2, sorry, and raise the power. So that's k to the minus 1, so that's an x on the bottom, plus some constant. So there's that. So there, so make it a little tidier. So v squared is k over x plus c. And now we put our values in. So when x is 2, I think v was 5. 2 and 5, 5 and 4 here. And each of these give us our equations that we can use to solve our simultaneous equations. So I substitute them into the system. I get 25 is equal to k over 2 plus c, and I get 16 is equal to k over 5 plus c. Subtract the two equations, and we get 9 equals k over 2 minus k over 5, common denominator, so we're going to get 5 minus 2, 10. So k equals 10 times 9 divided by 3, which is 30. Put that back into one of the equations we've got. So I'll put in the second one. 16 equals 30 divided by 5 plus c, 30 divided by 5, 6, so c equals 10. So now I get my equation of v squared equals k, which is 30 over x, plus my c, which was 10. Now some of you get this answer. The reason you get this answer is inside here, when you're putting your values of x in. Your values, because you've got the wrong sign, you're effectively doing two wrong signs together, which effectively cancel out. So some of you may have got this right answer. What you'll see written next to it is correct answer from wrong working. And that means that you don't get that accuracy mark either for just being there. You don't get particularly the method marks all the way through here either. I think it works out that if you made just this single error about sign here, if you make that error, then it should lose you about 4 of the marks. You keep losing all the accuracy marks and a couple of the method marks. So that minus is quite an expensive mistake.